Welcome to Lesson 1, Overall Concepts of the Getting Started series. In this video, we will explore the basic precepts of SDS2's functionality. I'll begin with the multi-user environment. When in the modeling module of SDS2, when a user adds, modifies, or processes members, all the users on the project will instantaneously see the results in real time. There's no saving of these operations required. The only operation that requires a save in the modeling module is the creation of erection views, which are snapshots used to create 2D erection or placement drawings. The pro about this functionality is that you do not need to be concerned with checking in or out files or accidentally overwriting someone else's work, which facilitates easy model management. The con is that aside from being able to undelete members, you are not able to undo or redo operations. This is not proven to be a major issue with our current users, and with the advent of the member undelete, even less so. In the 2D portion, Drawing Editor of SDS2, only one person can work on a drawing at a time, and the user is responsible to save the drawing. You are the automatic save. Since only one person is working on a drawing at the time, you do have the ability to undo and redo operations performed on the drawings. Next, I'll move on to what we call the central database theory. All the data is essentially contained in the model, and the data is extracted from the model, for example, drawings, CNC, and exports such as IFC, Sys2, and 3D DWG using the modeling tool. The key is that all the data contained in the 3D SDS2 model is then extracted. At this point, it is important to mention that once a drawing is created, if the model is modified, the user will be required to regenerate the drawing. The drawing will be indicated that it needs to be detailed again, but it will not be automatically updated. It requires the user's interaction to create the updated drawing. Likewise, if the drawing is modified, the model will not be modified to reflect the changes made to the drawing, since the drawing is only an extraction. Tools like DesignLink for imports, DWF import, and parametrics allow data to be imported into the SDS2 model. What we call parametrics are scripts written in Python code that allows users to add members and material to the model, search the model, and create reports from the model. Parametrics act as an API, application program interface, for the users, design data, and partnering companies. Reports and MRP exports for products like FabSuite, Steel Projects, and FabTrol can have their data extracted from either the model or the 2D drawings. Lastly on this topic is the ability to extract 2D DWG and DGN files. These are created from the SDS2 2D native drawings. Once a DWG or DGN is created, any piece marking link back to the model is severed. The creation of DWG or DGN for drawing cleanup is not encouraged, or is it required, since SDS2's drawing editor contains all the required tools. In the next major release of 7.3, 2D DWG and DGN files will have the ability to be added to the 3D model. SDS2 is self-contained using control files and an extensive file control procedure that enables this real-time functionality in the model. The user is not required to place and locate items such as drawings, since these are controlled and placed into the appropriate locations by the system. The point to take away from this is that accurate modeling and model maintenance is critical to the success of the project. This section will cover the detailer's workflow in SDS2. The first and most critical step is setup options. This is the brains behind the model. In my experience, many of the issues that arise in a project can be caused by improper setup. Setup will affect everything from connection design to piece marking to 2D drawing representation. Next comes the building of the model. A few basic points about the model are: SDS2 uses the term members instead of what some software would call assemblies. Bolts and connection material are part of the members as well as any user-added material. For example, when a material is added for a member, like a pour stop, no additional operations are required to connect the material to the member. When members are added, they are represented in what we call stick mode and can only become solid after an operation called process and create solids is performed. Stick mode does allow for very quick and accurate input of members. Once the model is complete, the 2D details, erection views, and submaterials are generated. The 2D drawings are modified in what we call the Drawing Editor module. These individual items called details, erection views, and submaterials are then loaded onto detail sheets, erection sheets, and gather sheets, which can then be plotted. I will quickly demonstrate this workflow. I'll first start off by changing to a new project. I'm going to copy the data files for setup from another project. Create the job portion of the project, which I'll explain later. Select the custom property flavor and the material file. Now let's view the setup and the data that we copied over from the other projects. Notice that you can change to the different design code. Let's take a look at the plate definition schedule. We can see that plates were carried across, zone and sequence. We can see that that was carried across because of the copy options. Let's go ahead and take a look at the member and material piece marking options. It's set to break members apart by sequence for the piece marks. Let's go ahead and take a quick look at some connection angles, clip angle, narrow gauge. There we go. We can go ahead and take a look at those. Okay, let's opening up our modeling. I'm going to add in a view name and an underside of base plate. Now, using what we call design link, I'm going to import a sys2 file. We can now see that the model has been added into the SDS2. Let's go ahead and unzoom. Rotate around into plan view, and now what I'm going to do is I'm going to select some members and then go ahead and change the sequence from 1 to sequence 2 for these members. Let's go ahead and process and create solids. The system is now going through looking at all the data, creating the connections, doing all the piece marking, all in that one shot. Let's go ahead and solidify these members in the corner. You can turn everything to solid or selected members to solid. You can change them to a transparent or a transparent main or back to stick. I'm going to go ahead and edit this member, set it to a clip angle configuration, and let's go ahead and set it to be a moment connection. SDS2 is designing the connections as per the input load. I'm only going to change this one member because the system was batched on those members. Notice how the connection has changed. We can see that because of the moment, stiffener plates are required in the column. And we can see for erection purposes it changed it to an extended pass flange connection. Let's go ahead and detail the members that are in sequence 1 only. I'm now creating the 2D drawings. Let's go ahead and view 1. There's the detail. There's the bill of material. Now let's go ahead and create the detail sheets. I'm going to place on sheet 1, selecting the sheet type I want to use, 4x36, and I'm going to add some of these details onto the detail sheet. This is the manual method of adding details to sheets. I'm also going to manually change the piece marks. When I change these piece marks here, they will be changed throughout the entire system. As I zoom in, I can see that the piece mark has been changed to 1B2. Let's go into the model. Looking at the model tree, I'm going to type in 1B1, and then I'm going to find that member using model tree and zoom to that particular member. Turn it to solid. There's the mark 1B1. Now, of course, it may be rather painful to individually load each member onto the sheets. So we've also created what's called a detail sheet auto-loading, where I can batch load members onto a sheet. I'm going to use strict columns and rows, set my piece marking routine, go ahead and hide any other members that are not in sequence 1. Any members that were already loaded on the sheet are not available on the list. And we can now go ahead and see that we now have these other sheets. Notice that they have all their piece marks that are added on here. These piece marks have been updated as per the convention that I chose throughout the entire system. This will conclude Lesson 1 Overall Concepts.